Waves come in many different shapes and forms. Waves in the ocean, waves along a guitar string so you can strum a tune, sound waves when you whistle, echoes in a cave, light waves from the sun. We need a way to categorize all these waves and to describe them. One way to categorize waves is to base it on how each individual particle moves in a wave. If the particles oscillate in a perpendicular motion to the direction that the wave travels, we call it a transverse wave. The ripples that you make when you drop a pebble in the pond is an example of transverse waves. When you heat up a bowl of soup in the microwave, you're using transverse waves. But quite the opposite happens when you push a slinky back and forth. The particles move in parallel to the direction that the wave travels. You're observing what's called a longitudinal wave. Where the wave is squashed together in a longitudinal wave, we call it a compression. The region that's been stretched is called rarefaction. Let's take a look at a transverse wave again. The maximum displacement is the crest. The minimum is the trough. From one crest to the next, that's the wavelength of a wave. Likewise, this is the distance between two consecutive troughs. If we draw an imaginary line halfway between the crest and trough, we are marking the equilibrium position of the wave's particles. What do we mean by equilibrium? If you put a marble at the bottom of a bowl, it sits there nicely and is not going to move. But if you displace the marble ever so slightly, it will want to roll down, oscillate back and forth, before settling back to its equilibrium position, kind of like a wave. If we draw a vertical line from the equilibrium to the crest, we are marking the amplitude. This is the maximum displacement a particle can make from its equilibrium position.